Hello student, good afternoon to all. Today we are going to learn some example of twinning system. This is the last part of that unit. Three example remaining left, and that is the last part of this unit. First example is very important example, means पेपर में जो आए थे वही एग्जाम्पल है. तो फर्स्ट एग्जाम्पल है, एट अ रेलवे स्टेशन only one train is handled at a time. The railway yard is sufficient only for two trains to wait while other is given signal to leave the station. The train arrive at the station at an average rate of 6 per hours, and the railway station can handle then at average of 12 per hours. Assuming the Poisson arrival and exponential service distribution, find a steady state probability of various number of trains in the system, and also find the average waiting time of a new train coming into the yard. Here, lambda means arrive rate. Arrive rate is here 6 per hours. Therefore, here the value of lambda is equal to 6. And average rate train arrive at the station at an average rate. Average rate means at an average rate 6 per hours. That is the arrive rate, means value of lambda. And railway station can handle then an at average of 12 per hours. Just service rate. That means service rate. Therefore, this is the value of mu. Mu is equal to 12. Then find the rho. Rho is equal to, you know, the formula lambda upon mu, and put the value of lambda and mu, that is 6 divided by 12, and that is equal to 0.5, and that is the value of rho. The maximum queen length here, two train, one is arrive and one is waiting, therefore two ट्रेन आर हियर, देयरफॉर मैक्सिमम क्वीन लेंथ मीन दोनों ट्रेन के बीच में की जो लेंथ है वो उसको बोलते हैं अपन क्वीन लेंथ. तो वो है 2, and that is the maximum number of train in the system is 3. 3 means one is arrive, one is service, and one is waiting for come the platform. Therefore, here maximum number of train in the system is 3. Then the probability that there is no train in the system, कोई भी ट्रेन वेटिंग में नहीं है, both waiting and in service. सर्विस में जो है और एक arrive जो हुई है, एक वेटिंग में जो है, इसका कैसे निकालते हैं? दैट इज P0, and P0 का फॉर्मूला है 1 minus rho upon 1 minus rho to the power capital N plus 1. And here we find the rho. Rho is equal to 0.5, and putting this value 1 minus 0.5 upon 1 minus 0.5 raised to the power capital N means number of train in the system. तो ये इस सिस्टम में कितनी ट्रेन है? 3. 3 plus 1, that is 4. Then after calculation, this value is equal to 0.553. And since this is the value of no train in the system, probability of no train in the system, कोई भी ट्रेन वहां नहीं है, सर्विस में नहीं है या वेटिंग में नहीं है, इसकी प्रोबेबिलिटी कितनी है? 0.53 है. Then find the Pn. Pn is equal to, you know the formula, Pn is equal to P0 rho to the power n. अगर वन ट्रेन है तो रो का पावर 1 होगा, ये वैल्यू P1 की होगी. 2 है तो ये इसका पावर 2, ये P2. तो पहले आपको P1 निकालना है. P1 is equal to n is equal to 1 means P1. P1 is equal to P0 into rho. You know the value of P0, that is 0.53, and rho की value is 0.5, and multiplication of these two is 0.27 approximately 0.27. Then P2 is equal to P0 into rho to the power 2. Then putting the value of P0, 0.53 into 0.5 raised to the power 2, then we get 0.13. Then P3 is equal to P0 rho to the power 3, that is 0.53 into 0.5 raised to the power 3, that is equal to 0.07. Then we find the E of n, means average number of train in the system. That is E of n. E of n is equal to कितनी ट्रेन है सिस्टम में 3 है, therefore n is equal to 1 to 3 n pn. Putting the value of n is equal to 1 into p1 plus 2 into p1 plus 3 into p3. Then 1 P1 की वैल्यू आपने ऊपर निकाली है 0.27 प्लस 2 इंटू P2 की वैल्यू 0.13 प्लस 3 इंटू P3 की वैल्यू 0.7 and after addition we get 0.74. This thus the average number of train in the system is 0.74 and each train take an average that is 1/12. That is 0.08 hours. आपको सर्विस रेट मालूम है इसका कितना है 12 है 12 पर आवर 1 आवर में 12 per hours इसका रेट है therefore the waiting means each train take an average means service time is 1/12 that is 0.8 hours for getting the service. As the arrival of new except to find an average 0.74 train in the system before it, and then E of W is equal to 0.74 into 0.08 and multiplication of these two we get 0.0592 hours. means hours के आपको मिनट करना है मीन्स मल्टीप्लाई करना है 60 से तो आपको मिलेगा इसका आंसर 3.5 मिनट and that is the E of W means arrival of new expect to find the average of 0.74 train in the system before it, that is EW is equal to 3.5 minutes. Then we see the second problem of queuing system, that is assume the goods train are coming in a yard at a rate of 30 train per day. 30 train per day है तो 30 divided by per day में कितने hours होते हैं 24, therefore 30 divided by 60 into 24 and suppose that the inter-arrival time follows an exponential distribution and service time of each train is assumed to be exponential with an average of 36 minutes. ये ट्रेन पर डे है ये मिनट्स है तो इसके पहले मिनट्स में करना पड़ेगा ये मिनट्स में दिए हुए. If yard can admit 9 train at a time, there being a 10 lines, one of which is reserve for shutting the purpose. 10 लाइन है वहां पे 9 ट्रेन एडमिट होती है लेकिन 1 जो लाइन है वो कैसी है शटिंग पर्पस में बंद की हुई है. The calculate the probability that the yard is empty and find the average queue length. तो means probability of yard is empty means yard को वहां कोई सर्विस टाइम नहीं है ये निकालना है and find the average queue length of the given problem. Here we find the first value of lambda, that is 30 train per day. Therefore lambda is equal to 30 divided by 60 into 24, that is 1/48 and mu की वैल्यू है 36 per एवरेज ऑफ 36 मिनट एवरेज है इसका तो ये वन ट्रेन 36 मिनट में आती है therefore mu is equal to 1/36 train. Then lambda rho is equal to lambda upon mu, that is 36. Putting this value, we get 36 upon 48, that is 0.75. ये problem पीछे भी हुआ है. Then probability that yard is empty. Empty means probability ऐसे कि yard को कोई काम नहीं है, उस टाइप की probability, that is P0. P0 का formula है 1 minus rho upon 1 minus rho to the power n plus 1. यहाँ 10 लाइन है, लाइन क्वीन लेंथ दी हुई है 10, तो therefore 1 minus 0.75 upon 1 minus 0.75 raised to the power 10 means यहाँ ट्रेन कितनी है 9 है, 9 plus 1 means 10, and then we get the value is 0.28. And average queen length is given by the formula A of m is equal to rho to the power 2 into bracket 1 minus n into rho to the power n minus 1 plus n minus 1 rho to the power n upon 1 minus rho into second bracket 1 minus rho to the power n plus 1. Putting here the value of n rho, and we get 0.75 bracket square into 1 minus n की वैल्यू कितनी है, ट्रेन है 9, तो ये 9 into 0.75 raised to the power 8, n is equal to 9 minus 1 8 plus 8 into 0.75 raised to the power 9 upon 1 minus rho, that is 0.25 into 1 minus 0.75 raised to the power 10, n plus n is equal to 9 10 plus 1 10. Then after calculation we get 2.22 into bracket 1 minus 0.303 upon 1 minus 0.005. Then division of this is 0.70. Then 2.22 multiplied by 0.70, and that is equal to 1.55. That is the E of n. E of n means average screen length is given by E of n, that is equal to 1.55. Then third problem of this unit, and that is the last problem. Important है. A supermarket has 2 girls servicing at counter. 2 girls service दे रही है काउंटर पर. The customer arrive in the Poinson fashion at the rate of 12 per hour. The service time for each customer is exponential with the mean 6 minutes. सर्विस रेट ये है मिनट में, और कस्टमर का अराइव रेट है 12 पर आवर्स है, और आपको फाइंड करना है प्रोबेबिलिटी दैट एन अराइविंग कस्टमर हैज टू वेट फॉर सर्विस, एवरेज नंबर ऑफ कस्टमर इन द सिस्टम, एंड थर्ड है एवरेज टाइम्स स्पेंड बाय कस्टमर इन सुपरमार्केट. तो पहले आपको लैम्बडा की वैल्यू कितनी है, 12 कस्टमर पर आवर्स. 1 आवर्स में कितने कस्टमर आ रहे हैं वहां पे 12, एंड म्यू है, म्यू इज इक्वल टू 10 पर आवर्स. तो 10 पर आपको दिया क्या है, सर्विस टाइम फॉर ईच कस्टमर विद मीन 6 मिनट. 6 मिनट है एक कस्टमर को, तो 1 आवर में कितने लोगों को सर्विस मिल सकती है, तो फॉर वन सर्विस दे रिक्वायर 6 मिनट, कल 6 मिनट सर्विस. Therefore 1 आवर्स में कितनी, 60 डिवाइडेड बाय 6, 10 लोगों को सर्विस मिलेगी. Therefore म्यू means service rate is equal to mu is equal to 10 per hours, और lambda is equal to 10 per hours. इतने एक आवर्स में 12 कस्टमर आते हैं और सर्विस 10 लोगों को मिलती है, और वहां चैनल कितने हैं, 2 है. Therefore C is 2. Then put the value of P0. P0 is equal to n is equal to 0 to C summation n is equal to 0 to C minus 1. C minus 1 में चैनल कि कितने यहाँ 2 है तो 2 minus 1, then 1 upon n factorial into lambda upon mu raised to the power n plus 1 upon c factorial lambda minus mu raised to the power c mu upon c mu minus lambda and whole bracket raised to the power minus 1. And then put the value summation n is equal to 0 to 2 minus 1 channel वहां पे 2 है तो therefore 2 minus 1 upon 1 upon n factorial means कितने नंबर है वहां n की वैल्यू 0 से स्टार्ट होती है n upon 0 factorial means 1 एंड लैम्बडा की वैल्यू आपको 12 कस्टमर पर आवर्स है तो 12 डिवाइडेड बाय 10 6 मिनट 1 कस्टमर को सर्विस होती है तो 1 आवर्स में कितने को 10 को so therefore 12 upon 10 raised to the power n plus 1 upon 2 factorial into 12 upon 10 raised to the power 2 into 2 multiply c multiply by mu, that is 2 multiplied by 10 upon c mu minus lambda. Lambda की वैल्यू है 12 and c into mu 2 minus 2 multiplied by 10, that is 20. Then 1 upon 2 factorial into 10 12 upon 10 raised to the power n की वैल्यू 0 है तो putting here 0 1 2 and then we get 1 upon 0 factorial and that is the value is 1, therefore this is 1 plus 1 upon 1 factorial means 1 12 upon 10 6 by 5 raised to the power 1 plus 1 upon 2 factorial means 1 by 2 into here 6 upon 5 raised to the power 2 and that is 5 by 2 and whole bracket raised to the power minus 1. Then after calculating we get 1 plus 6 by 5 plus 1 by 4 into 36 by 5. That is 1 plus 6 by 5 plus 9 by 5 raised to the power minus whole bracket raised to the power minus 1. 1 plus 15 by 5 means 3. 4 raised to the power minus 1, that is 1 by 4. Therefore 1 by 4 means 0.25. 4 ने इस पर को डिवाइड किया तो उसकी वैल्यू आती है 0.25 means probability of no waiting is P0, that is 0.25. Then probability of having to wait for a service, that is PW greater than 0, that is equal to 1 upon c factorial lambda upon mu raised to the power c into c mu upon c mu minus lambda into P0, and that is 1 upon 2 factorial. Here 2 channel are present. Lambda upon mu is 12 upon 10 raised to the power 2. Here c multiply by mu की वैल्यू 10 है 20 minus 12 नीचे into 1 by 4. Then after calculation we get 1 by 2 6 by 5 square 5 by 2 into 1 by 4 and that is 9 upon 20 and this is equal to 0.45. This is the value of probability of having the wait for the service. Then average pin length, that is E of M. E of M का formula है lambda into mu into lambda upon mu raised to the power c into P0 upon minus c minus 1 factorial into c multiply by mu minus lambda to the power n. N की value है 2, therefore here 2. Then putting value 12 multiplied by 10 multiplied by 1.2 to the power 2 plus into 0.25 upon 2 minus 1 factorial 20 minus 12 square and that is 27 divided by 40. Then the average number of customer in a system is E of n is equal to E of m plus lambda upon mu. Next previous lecture में आपने ये formula देखा है average number of customer in a system E of n is equal to E of m plus lambda upon म्यू, और ये ऑफ यम आपने ऊपर निकाला ही है, वो है 27/40 प्लस लैम्बडा फॉर म्यू 10/12/10 एंड दैट इज इक्वल टू 1.87, और ये पॉइंट के ऊपर बाद में 8 है, ग्रेटर देन 5 है, तो हियर 2 कस्टमर approximately waiting. Average number of customer in the system is 2, approximately 2. Then average time spent by customer in a supermarket. तो वो कैसे निकालते? E of E is equal to E of N upon lambda. तो E of N आपने निकाला है 1.87 डिवाइडेड बाय लैम्बडा. लैम्बडा में कितने पर्सन है वहां पे, अरीव रेट कितना है, 12 है, तो डिवाइडेड बाय 12 एंड दैट इज 0.156 आवर्स. मींस ये इतने हवर्स है, तो इसको 60 से मल्टीप्लाई करो, मिनट में हो जाएगा 9.3 minutes. That is the value of average time spent by customer in the supermarket. These 3 problem are very important problem in this unit. ये करो, और यहाँ ये यूनिट नंबर 4 क्वीनिंग सिस्टम फिनिश हो गया आपका.